Hello, hello student. I hope I am audible now. So in the last class, we discussed about the graphical representation of the classes. Classes are represented uh, either in the simple form or using three compartments. First for the name, second for the attribute, and third for the operation. Okay. So simple representation of the classes or with the part name, the attributes, the different ways the attributes and operations can be represented. We discussed in the last class. Optionally, responsibilities also can be represented with the classes in fourth compartment. Then we discussed about the various relationships that can be there with the classes in the class diagram. So between the classes, there can be dependency relationship, there can be association, or there can be generalization relationship. Usually, dependency relationship is used when semantics of one class, if there is change in the semantics of one class and that invites changes in the semantic of other class, then between these classes, the dependency relationship is shown, that is usually shown in the dotted line. Then the generalization relationship is shown to show the base class and subclass. So that is how it is shown here. Window is base class, rectangle, circle, and polygon, they are the subclasses. Whereas the rectangle class works, or it is working as the subclass as well as the base class for square. Okay. Then association has got various different things. For example, you can have name for the association. For example, here the name given is works for. So you can read this particular association between two classes as person works for company, like that. Okay. So there is a direction in which you need to read the association name. So usually an arrow is given or represented here. So this particular arrow is towards the, it should have been towards the company. Okay. So person works for and the role of the company in this association is employer. Okay, so what is the role played by the object of that particular class is specified at the end of the association, and that is for the role name. It is quite possible that between the two classes there can be two different associations, and the role played by each of the role played by the class in the different association may be different. Okay, so a class may play different role in the different association. Okay, so that we shall see later. Multiplicity is one of the important, you can say, notation. Just a minute. Multiplicity is one of the important features that is used with the association, and it carries significant information. Yesterday I told you how to read this particular multiplicity. So this particular multiplicity should be read in this fashion. That is, you read it from one class to the other class. So it is read like this: every object of the person, every object of the person uh, interacts with many objects of the company. So this is one direction in which you read the association, whereas in the other direction, you read it like this: every object of the company interacts with or associated with one or many objects of the person. Okay, so this is how you make two different statements based on the on this particular multiplicity. The multiplicity does not necessarily define the number of objects of the company or number of objects of the person. Okay, so this is very important. This is the common misinterpretation of the multiplicity, that this multiplicity many times students interpret it like this, that is, uh, there are one or many objects of person and there are many objects of the company. It is not like that. Okay, it is with how many objects, how many objects of this particular person interact with a single object of a company. So that is the interpretation of this particular multiplicity. Okay, so again I read it out once again. Every object of the person interacts with many objects of company. So this is one statement. The another statement is every object of company interacts with one or more objects of person. Okay, I hope you understood now this particular multiplicity that is shown with a association. Okay, then aggregation is one of the important, or it is one of the specialization of association. There can be association between two different classes, and this association is such that one class is part and another class is whole. Okay, for example, there is a class company and there is another class that is department. Here, the department class is part of the company. Okay, so the relationship between this, the association between these two is that because the department is a part of the particular company, so that is why there is interaction between the company and department. Okay, so because company is whole and it is part, the department is part, then this particular association can be represented with their body aggregation. Okay, so a diamond, a hollow diamond is shown on the whole part. Okay, so this is a special type of association and it's called aggregation. Okay, so for example, in the classroom. Okay, for example, if the room is the class, then what can be the classes which are part of that particular room? For example, the desk or the table, they may be, or the chairs which are there in that particular classroom. So they are the part of that particular classroom. Okay, so like this, it is the analogy, physical analogy we can have with the aggregation. So between the classroom and the desk in the classroom, we can show aggregation kind of relationship, because those particular desks, they are part of that particular classroom. Okay, so that is the aggregation. Okay, so aggregation is a special kind of this thing, association. Okay. Now there are certain examples. For example, here the course has been shown here, which is dependent or this course schedule is dependent on course. So dependency relationship is shown actually because of uh, conversion of this particular slide. This actually this slide has to be dotted line. This particular arrow has to be dotted line. Okay, so that is why, but it is showing because of the conversion problem, the solid line, but because it is a dependency, it has to be a dotted line. Okay. Again, the iterate the friend class. So again, the friend class, because it is a friend class, so it is dependent on this course schedule. So a dependency relationship between the iterator class and course schedule class. So dependency relationship can be modeled in this fashion. If uh, content of one class changes, it will invite change in the content of the other class. Okay. Here is another example of the class diagram. Security is the base class. So when we want to model the inheritance, then in that case we use the generalization relationship. Okay, so this is the generalization relationship. Which is shown with the solid line with hollow arrow. Okay, so again, there is because of the conversion of the slide, the arrow has been modified over there. Let me see if the PDF version of this is available. If it is available, then I would be able to show the correct one. No, it is not available right now with me. Okay, anyway, when I hear this particular PPT on the LMS, then the representation will be, will see that the representation is proper. Okay, then this is again another class diagram. Now there is a lot of information that you can make out from this particular graphical representation of the class diagram. Okay, so you can make many statements from this particular class diagram. Okay, for example, when you read the associations, now you can see that there are associations. Students are member of school. Okay, so this is how you read this particular association. Okay, students are member of school. Okay, then the association, rather this is aggregation. Okay, special kind of association. Okay. Then here is the another relationship, that is composition. Okay, so actually one more relationship is there, that is composition. For example, I will come to this particular slide to show one more type of association. So this is composition. Again, it is a special kind of aggregation. When there is association between two classes, when there is association between two classes, and the association is such that one is the whole and another one is part. Okay, so that is applicable to the aggregation also, but here the aggregation is much stronger. In this case, the aggregation is much stronger such that the whole and part, lifetime matches with each other. Okay, that means the lifetime of the whole and lifetime of the part, so they coincide with each other. Okay, so that is creation of the object of the window and creation of the object of frame, and destruction of the object of the window and destruction of the object of the frame. So it coincides with each other. Okay, for example, in case of the classrooms, the lifetime of the classroom and or the desk or chairs in the classroom, table in the classroom, they are not permanently the part of that particular classroom, because the desk and chair can be moved to some other classroom also. Okay. But there are certain things which are part and parcel of that particular classroom, which you cannot move. For example, walls of the classroom, the ceiling of the classroom, the floor of the classroom. So all these things, they are the lifetime of the classroom and the lifetime of the walls of the classroom, the ceiling of the classroom, floors of the classroom. So it coincides with each other. So if you want to show the relationship between the walls of the classroom and classroom, it is the composition relationship. Okay. So this is how you show the composition relationship between these. Okay. For example, here windows and frames. So on the window there are frames. Let us say frames. So if you destroy window, then or if you remove window or delete window, the frame on that particular window also will be removed. Okay, so this is how is the composition relationship between the two classes. Okay, so like that you can have composition relationship. Okay, so coming back here, uh, coming back to this particular slide. So between the department and school, there is a composition relationship. Okay, so you might now might have observe here the relationship. Okay, students are part of the school. Okay, so students are part of the school, but the how is this particular association? It is aggregation. Okay, that is for some period of time. Let's say for 4 years, the students are part of this particular school. After that, they become the alumni of this that particular school. Okay, so they are not permanently associated with the school. So that is why here the aggregation is used. Okay, whereas the school has various departments, and those departments they are permanently the part of that particular school. Okay, so there is a relationship called the association, sorry, the composition relationship between the school and the department. Okay. So is the case with the course. Okay, so there is association between the course and the department. Okay, so because the department runs the courses, so there is association between them. Because student attains the course, so there is relationship between the course class and the student class. So student attends the course. There is there's association between instructor, or you might call it as teacher, and the course, because the instructor teaches that particular course. Okay. Then there is association between the instructor and the department. Again, it is whole and part, because the instructors, they are the part of the department. So whole and part relationship. So because the instructor is assigned to a particular department, so that is why there is whole and part relationship between them. Okay. Whereas there is one more association between the department and the instructor, and why is that particular? What is the role played by the instructor in that case? The role played by the instructor is the chairperson. Okay. So if one of the instructors is the chairperson of that particular department, okay, for example, HOD of that particular department, so that is another, that is what there is a relationship between that instructor and that particular department. Okay, so the role played by the instructor here is the chairperson, whereas the role played in the other way, it is that that particular instructor is going to be a teacher for in that particular department. Okay, so like this we have read the different association, why there are associations between the different classes. Okay, so school, student, course, instructor, department, these are the classes in let us say one of the educational system. Okay. Having read the associations, now we need to focus on the multiplicity that have been shown with each of this particular association aims. Okay. So how it is to be read? Uh, so again, I would like to mention here that the multiplicity that is shown everywhere. So it does not mean that it is the number of objects of that particular class. Okay, so it has different meaning. Okay, for example, if you want to read the multiplicity between the school and the department, so there are multiplicity at the end of the association. So it has to be read in this action. Every school object is associated with one or more objects of department. Okay, or every school has one or more department objects. Okay, or in the reverse fashion, if you want to read, then every department is associated with one school object. Okay, here you can see that the multiplicity is only one. Okay, so one department cannot be associated with more than one school. Okay, so every time if you consider a particular department, then that particular department will be associated with one school object. Okay, but a school object it may be associated with one department or many departments. Okay, so in a school there can be one or more departments. Okay. In the similar fashion here, between the school and the student, every school object is associated with many student objects. Okay, so every school may have many students. In the reverse direction, every student may be associated with one school or many school. Okay, so that means it might be that the students have taken admission. It happens very less number of times that student has taken admission in more than one school. Okay, for example, one may be the educational school, another school may be, let us say, the musical school or some driving school and like that. Okay, so in that case, it is possible that a student is a person is a student of more than one school at a time. Okay, so that is how it may be like that. Okay, or the student may be doing various courses, and those particular distance courses they are of the different schools. Okay, so every student may be associated with one or more schools. So this is how is represented here. Between the student and course, every student object is associated with many courses. Okay, so a student may take many courses at a time, or every course may be associated with many students. Okay, or a given course may be a given course object. Okay, a course object means the different courses. Okay, so there are different courses. That means there are different objects of the courses. Okay, so every course object is associated with many students. Okay, then between the course and the instructor, how this multiplicity has to be read. Every course object has at least one or many instructors. So a course may be taught by one instructor, or it may be taught by combined by two or more instructors. Okay, or one instructor or an instructor may be associated with many courses. That means the instructor may be teaching either one course or it may be teaching two courses. Okay, so multiple courses may be given for the instructor for teaching. Between the course and the department, the multiplicity, how it can be read. Every department object has one or more courses associated with it. Okay, or in reverse direction, every course is associated with one or more, or every course may be associated with one or more departments. Okay, so that is how the multiplicity has to be read. Between instructor and the department, every instructor is associated with one or more departments. Okay, so quite possible sometimes a person may be working in two different departments, teaching the two different subjects in those particular departments. Okay, and reversely, every department is associated with one or more instructor of theirs. Okay, for the second association, uh, between the department and instructor, every department has zero or one chairperson. Okay, so usually sometimes there may be no chairperson for the department, but sometimes there can be one chairperson for the department. Okay, whereas in the other way, the instructor may be associated with zero department or more than one department as a chairperson. Okay, so this is how this particular multiplicity has to be read. Okay, so I hope all of you have understood what is being interpreted by this particular class diagram. Okay, so though this particular class diagram, there are no description. Everything is shown graphically. So with this particular graphic, there are many things which are represented. So just now I have read out all those things. Okay, so though all these things are there, so it may be in the problem domain or in the solution domain. All these things, they are written in the descriptive form, and for that particular purpose, we have drawn particular class diagram. Okay, I hope you have understood this particular class diagram. Okay, so the class diagrams, they may be drawn for different purposes. So here is again another class diagram. In this, we have shown the association between the various classes. There is aggregation, a composition relationship between driver and steering motor, main motor. So this is modeling a simple robo. Okay. So class diagram, it can be drawn not only for the software things, but it can be drawn for the hardware things also. Okay. Then this is again one interesting example of the class diagram. So here you can see that all the classes, they are shown persistent. Okay, so these are the persistent classes, meaning these probably are the classes which are permanently stored, and this particular, or the information in this particular classes is permanently stored. So that is why these particular classes, they are written here as the persistent. Okay. So school is the class, department is another class, student, course, and instructor. Okay. So same classes, but persistent is written here. That means whatever you are going to store with this, so it is permanent or persistent, or it will not. It will last for a long time. Okay. So probably these are the tables in the database. Okay. So these are the tables in the database. This is a replacement to what you draw. You draw the ER diagrams. Okay. So in the DBMS, you draw the ER diagrams, and you show the relationship between those particular diagrams. So in the similar fashion here, a class diagram is drawn which looks similar to that particular ER diagram, but it has got more information than particular ER diagram. In the ER diagram, we show only the names of the tables and the attributes of that particular table. But in addition to that, here the operations are also shown. Okay, so though these are tables, usually with the tables associated with each of the tables, they are the procedures and stored procedures, you can say. and those particular stored procedures and that particular table form the class, okay, in our system, okay. So already this particular association, maybe the aggregation, composition. So we have already seen with the business layer classes. Okay, so we can have these particular classes at business layer also, but the purpose of the classes at the business layer and at this particular layer, that is the persistent layer or the access layer, it is different. Okay, so this is the another class diagram which is drawn, which models a schema or a database. Okay. So I hope you understood this. Now, when we are working with the class diagram, then there are two different concepts that we should understand. One is the forward engineering and another one is the reverse engineering. Okay. What is forward engineering, a class diagram? The forward engineering consists of converting the design or model into the implementation. So getting the code from the design is the forward engineering. Okay. So you have different tools to do this. Okay. So for example, here is one class diagram, and when you forward engineer this particular class diagram, then automatically you get a code like this. Okay. So this is called forward engineering. Okay, so this is the class diagram. This is the design that is prepared, and when you use some tool or by forward, when you use forward, you do the forward engineering, then you get the code in Java. Okay, so you can specify the target language. If you specify Java, then you get a code something like this. If you specify the target language of C++, the code would be something different, which has the syntax of C++. Okay, so that is the forward engineering. Okay, whereas what is the reverse engineering? If you already have the code, and from the code, if you want to prepare a model, okay, so forward engineering is from model you get the code. Okay, whereas the reverse engineering is if you have the code, and from the code, if you want to get the model, then you use the tool, and that particular tool will convert that particular code into the model. Okay, so that is the reverse engineering. Okay, so to let us say you have this particular code. So from this code, if you reverse engineer this code, then probably you will get a diagram like this. Okay, so like this, with respect to the class diagram, this forward engineering and reverse engineering is practice. Okay, what is the advantage of the forward engineering? Because from the design you directly move to the construction or implementation, and if your model is strongly specified, then you get most of the code, most of the implementation. So you need to write only the rest of the code so that your system becomes functional. Okay, so the forward engineering class diagram, it gives you the code which is consistent with your model. Okay, so that is again very important, that your code is consistent with the model or the design you prepared. Okay, so that consistency is very much required, because at a later stage, when you are debugging the system, you may not directly go for debugging at the code level, because the code is very huge. Debugging at the code level may be difficult than debugging at the model level or at the design level. Okay, particularly when you are going for strategic, when you are going for modifications in your system. Okay, for example, something has to be changed. Some major change is there. So in that case, you will not directly go to the code, but you will make changes in your design, and then you will incorporate the changes in your code. Okay, or that is your implementation. Okay, So you must know the forward engineering and reverse engineering with respect to the cloud diagram. Okay. So today we shall stop here. If you have any doubts regarding what we discussed in today's class, then you can ask. Uh, I don't know why so very less number of students were present in the class. Uh, is there any dive today evening? Somebody can unmute and respond to me. We are not done with the class. We will wait here for some time. Still there is some time. Let me see how many students have marked the attendance. There were not more than 20 students, but here, to my surprise, 30 students have marked the attendance. Hmm? I don't know. Uh, Let me call each one of you. If you are present, then I will mark you present. Otherwise, I am going to mark the absent. Okay. Is Dirisha there in the class?
Yes, sir.
Okay. Pooja Bade is there. Is Pooja Bade there in the class? Unmute and respond. Not there. Marking her absent. Is Vaishnavi there in the class?
Yes, sir.
Okay. Is Pooja Bhattise there in the class? Roll number 7. Hurry up. Okay. Hmm. Is Tanmaita there in the class? Roll number 8. Is she there? Not there. Okay, she will be marked absent. Akshay Bhamre. Akshay, are you there?
Yes, sir. Yes, sir.
Okay. 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 Then Nikhil Bhaskar is there. Is
Yes, sir.
Nikhil Bhaskar? Okay. So Nutan Bhosle is roll number 13.
Yes, sir.
Okay. Ashish Bidwe. Ashish Bidwe. Is Ashish Bidwe there? No. Absent. Monali Tharmal. Monali there in the class? No. Absent. Is Vaishnavi Chaudhary in the class? Vaishnavi Chaudhary? No. Absent. Is Santosh Chavan in the class? Santosh Chavan, roll number 21 in the class? No. Absent. Samiksha Rahe? Is Samiksha there in the class? Okay.
Yes, sir.
Okay, okay. Yashwant Gange. Is Yashwant in the class? No. Ashutosh Darpal. Is Ashutosh there in the class? No. Absent. Is Mrudula Dehado in the class? Mrudula, is she there? No. Kalyan Deshmukh, roll number 28, Kalyan Deshmukh, is she there? No. Pranay Deshmukh, not there. Shubham Dharak. Is Shubham Dharak there?
Yes, sir.
Okay.
Yes, sir.
Okay. Roll number 31 present. Swam Dixit. Are you listening, Swam, to me? Hello, Swam. Are you there? Not there. Prashant Dukle, are you there? No. Huh? Passman. Okay, next, Subhanji Gade is there. Gade is 1 number 37. No. Shanika Gaikwad. Shanika Gaikwad, roll number 39. Absent. Rushikesh Gavane, roll number 40. Absent. Roll number 46, Shailesh Yadav. Is Shailesh there in the class?
Yes, sir.
No. Okay, brilliant. Shailesh. Suyog Yadav. Is Suyog Yadav there? Roll number 47. No, absent. Swati Yadav, roll number 48. Swati Yadav is she there?
Yes, sir.
Present? Okay.
Yes, sir.
Okay. Swati Jandra, roll number 49. Swati Jandra, roll number 49, not there. Roll number 50, Vasanti Jandra, is she there? Is she there in the class? No, absent. Then roll number 54, Saili Cooper. Is Saili there in the class? No, absent. Aditya Loda, roll number 58. Is Aditya there in the class? No. Roll number 59, Varsha Lokhande.
Yes, sir.
Okay. Varsha is there. Then roll number 67, Sanket Patekar. Is Sanket in the class? Roll number 66. Roll number 66. Present? No. Roll number 69, Suraj Vashankar. Is Suraj there in the class? No. Rutu Sonawne, roll number 78. Yes, is Rutu present in the class? No. Absent. Rachna Tribhuvan, roll number 81. Is Rachna Tribhuvan present in the class? No. Absent. So all these are marked absent. If anyone present in the class and is marked absent, let me know. You can verify your attendance. Yashwant Dharanji, are you there? Unmute yourself. And, have I marked you absent?
Yes, sir.
Roll number 25.
Sir, I was there, but mobile not.
Huh? But I called you, na? Hmm? Okay, I am again marking you present.
Yes, sir.
Check it now. Whether you are not present or not.
Yes, sir.
So it is happening that some students are just marking the attendance and they are leaving the class, so that is not recommended. So only today attendance is only 14. Only 14 students are only 14 students are present in the class. I'm marking now rest of the students absent. Roll number 7, Pooja, what you say you are marked present? Okay, you are roll number 7, you are present. Okay, so we shall stop here. In the next class, we shall continue with the domain analysis with the case studies. So we have seen a lot of syntax related to UML diagrams, various diagrams. In the next class, we shall see the case studies. Okay, so maybe related to your mini projects or the final year projects. You may leave the class now. Okay, bye. All of you leave the class. If anyone is there in the class, the recording will continue. Nikhil Bhaskar, Shailesh Jadhav, Vaishnavi, Vaishnavi, leave the class.